All right. Hello, folks. I'm Vera van der Sijp, and I'm part of the Future Sketches group at the MIT Media Lab. Thank you so much for joining us today at our first session of the lunch lectures about generative AI and artistic practice. Just so you know, we will be recording these meetings. Yeah, if you're not okay with that, please be aware that you can switch your camera on or off as you like. And yeah, just know that we do that. That also means you can look at the talk later on. Also good to know, well, you managed to get in, there's a passcode that we have on our page. So if people have trouble getting in, just know that that is something that we need. And if you have any questions, you can post it in the chat. I'll just quickly introduce this series because this is like one of the lunch lecture series that we're hosting. And this one specifically will be focusing on artists that think about and work with generative AI. And we started that because the use of generative AI and the tools have advanced like really rapidly over the past year, especially. And they've saturated our public consciousness, and it's something that even outside of creative circles, people are talking about right now. And that raises a lot of questions. So yeah, how visual artists can engage with this. And also, if you're an artist or a creative, what are the ethical implications and how do we deal with that? And what are maybe holistic means of co-creation, and maybe also pitfalls that we should be avoiding. And yeah, as a group, we're talking about this a lot at the Media Lab, but we also feel like it's important to open up that conversation and also see at people in the field working with this. And I'm really excited to introduce our first speakers of today, people that I'm really, really admiring and already have followed for a long time. And that is Sofia Crespo and Feileacan McCormick of Entangled Others Studio. And yeah, they're both visual artists working with artificial intelligence, but also really thinking of how to combine that with biology. So they kind of explore how organic life uses artificial mechanisms to simulate and how it can evolve. And then they have Entangled Others Studios together, where they explore moving further into an entanglement with the more than human world. Yeah, they basically bring a lot of things into question with their practice, and have already worked with this before this became like a kind of more popular medium. And their work, I think, brings into question the potential of AI in artistic practice and the ability to reshape our understanding of creativity. So yeah, thank you so much for joining us. So I'll give you the floor, and please, if you are in the call, make sure to mute yourself and post any questions you have in the chat. Entangled Others Studio.
Thank you so much for the wonderful introduction, Vera, and thank you so much to everybody who joined today. Yeah, as Vera very well introduced, my name is Sofia Crespo, and I'm here with my collaborator for the past 3 to 4 years now, Feileacan. And yeah, well, I'll just get started on some of our thoughts and kind of ideas behind our work. I really like to show you one of my old microscopes. That's something that I'm really fascinated by, the microscope as a technology and how it has shaped or actually influenced our understanding of nature. And what the microscope does is just it makes available to us a whole scope of things that usually aren't really visible to the naked eye. So it's like it's showing us something that is there, but that we can't always directly perceive. And that's something that absolutely fascinates me about it. And these are for like a few examples of things that I have looked at under my microscope. This is an example of crystallized vitamin C. And just by using like polarizations, you can actually achieve this wonderful effect where the colors are refracting in a very specific way. So it's just something that I personally feel absolutely fascinated by. And now, what does this have anything to do with AI, and why would I even bother to talk about this? And one of the reasons, or kind of a parallel threads I see here between the microscope and AI as a tool, is that they both allow me to see things that I wouldn't directly always be able to visualize. So of course, like they don't function in the same way, and they're not even built for the same purpose at all. But when I use AI as a tool, like the way that I see it is AI is a set of pattern extraction tools and pattern recombination tools, at least applied to my artistic practice. And that's something that I make a point about using it in that way to recombine something that is already there. So yeah, throughout my, well, you could say throughout my artistic experience, of course, like one doesn't always just become an artist overnight. Very often it's something that has been brewing for a long time. And in my case, when I was very young, I had an encounter with a jellyfish, and that was a virtual jellyfish, and it really influenced me, because when I saw it, I thought that it was real, but it was a jellyfish projected onto a screen on a 3D cinema with those old kind of 3D glasses. And after seeing that, later on, I found myself revisiting the jellyfish and wanting to recreate jellyfish textures. And I was using 3D render tools to do that. And then suddenly, the jellyfish became the subject of one of my very first explorations with AI. Now, these images you see here have been reworked. Of course, like the original ones, they looked a lot lower resolution. They didn't look like this on my first run. It also took like a long time to kind of get them to look like this. But I found myself generating these kind of combinations of jellyfish-esque textures, and kind of asking myself, what does it mean to be generating these things that look like life forms that I've seen before, but that aren't. So Feli, I don't know if you'd like to help in here.
Yeah, so going back a few years now, there was this website that was put out called "This Person Does Not Exist," wherein you could, click refresh, and every time you'd be greeted with another person that doesn't exist. And at the time, this was really quite cutting edge, and humanoid faces looked quite realistic if you didn't know where to look for the little bit of tell. And kind of as a response to that, we sort of started to explore, okay, this is interesting, but we're, very interested in the more than human realm. And for us, AI, I mean, we're not engineers, please, we're not in for any of this, so don't shoot us if you are an engineer in the audience. But for us, what's very interesting, especially working with visual neural networks, is that they act as a form of distillation. They extract, especially GANs in this case, extract patterns and learn to build patterns from the data set. And what you see here is then our little response to this jellyfish does not exist. And this was, a lot of fun to make. But when we were finished with that, having, created the big data set, trying to collect what was available with jellyfish and so on, what we realized was that actually these aren't really jellyfish in the sense of what jellyfish are like, because it turns out that everyone is, familiar with the metamorphic cycle of the butterfly, right? Which has these three distinct stages, where you have, the caterpillar, the pupa, and then finally the butterfly, which then lays an egg. Jellyfish, on the other hand, have, usually some 7 stages of their metamorphic life cycle, which are really vastly different in form, and they can even go backwards and regress, making them, in some cases, almost functionally immortal. But all the data we could find about jellyfish was this one stage, the medusal stage. And this was really interesting to us. So, then we tried to explore, how can we try and talk about the fact that we don't really have much data available to us about all these fantastic life cycle stages of the jellyfish? We don't really think of the jellyfish as this incredible morphing being, compared to a butterfly, right? You think metamorphosis, you think butterflies. So then we tried using a mixture of genetic algorithms and sort of custom built things for GANs to cross-breed neural networks trained on jellyfish from what we could find of jellyfish. And then, of course, with a far more ample data of, butterflies, caterpillars, and pupas, and blend these together, trying to explore how can we start to talk about that which we do not have data about, in a way, sort of trying to, we trace the boundaries of our imagination, in the sense that all the data that's available to us that we could train a neural network on is also saying something about the limits of our knowledge, or what, is common knowledge to us. And that's kind of an interesting thing to try and start pushing at those edges. But before we ramble, we can move on a little bit. There's more. So
Yeah.
Go ahead.
Yeah, so this might sound a lot more glamorous than than it really is. In reality, a lot of our practice behind the scenes looks like this when things are working, and this is like best case scenario. Things are running and everything is smooth, But the reality of it is that a lot of times things aren't running, a lot of times things are breaking, and sometimes it's part the fact that Feileacan and I were not engineers by training, so we've been kind of like putting things together from information that courses that we've done, and kind of all our knowledge is like very everything is like stitched together, and we don't have like a robust foundation for what we're doing. So yeah, I think it's important to know that, like when you're trying to train your own models, when you're trying to like use tools and kind of modify them, or, build on top of what somebody else has built, like it doesn't always look like a very smooth, a very smooth process. But to kind of summarize what we are doing, the way that we approach it is as a meditation on a specific topic or a specific question that we want to ask ourselves. And it usually starts with a data set, with thinking, what kind of data can we use? Or sometimes it even starts with, what do we want to make? And then we think, okay, this is the tool that we can use. This is the data that we can find, maybe, and train a model to do that. And so we kind of gather a data set sometimes that for us that has meant like very few images, or even like millions of images. And that has meant like just one day of training, or it even has meant at some point even 2 months of training a model. So it has varied over time. And that's also because computation has increased a lot for us. You know, when we started, we didn't have the tools that we have available now. Everything was much rougher to use, and it wasn't as easy as it is today. Things got a lot more accessible with time. And then there's a training process in the middle, and then there's an output exploration process. Both the in and the out, they involve some curation from our end, you know, to think like what data do we want to have. It has to be purposeful, you know, we have to really curate what goes in, and we also have to curate what comes out, what we like out of that, and sometimes that feeds back into the loop, and that becomes part of the data that feeds in to the training. And something that has been more and more important for us to do is to actually create our own data. When we started, we didn't have the possibilities that we have now, like going, you know, diving and photographing, because we're very, very much inclined towards the aquatic. So that's where a lot of our inspiration comes from. And you know, we didn't have the kind of possibilities to go on photography, because it's not that easy to do that, to capture wildlife in an aquatic setting. But with time, that's something that we have invested a lot of time and effort in doing, both extracting images, videos, but also we have collaborated with a good friend of ours who's a great artist, Robertina Shibianic. I highly recommend checking her work, by the way. And she has been for many years already recording sound underwater. And yeah, a lot of her projects are about like sound pollution and kind of ecology of aquatic environments. And we've also been working with aquatic data as well, like using aquatic sensors and yeah, plotting aquatic data. So just to show a few inspirations, in case you're wondering, well, what actually inspires you, you know, to get here with your work. And part of our inspirations really comes from the movement of artificial life, which unfortunately I kind of missed because I was born in 91. I was a baby. I wasn't around to really understand what was going on. But artificial life, at least for software, had really amazing years from the 80s to the beginning of the 90s. And there were artists like William Latham or Carl Sims. There are just very few examples. Of course, there are a lot more. And the work really touches on this idea of simulating something that looks organic, some kind of organic behavior in a software. So in a way, this is very bottom up because they build their own software. For example, here, Carl Sims has built a full like simulation, a full like physics engine on what back then was considered a supercomputer, which no longer stands as a definition of what a supercomputer is. But to kind of simulate these creatures that actually, you know, they interact with each other, they move in an environment, they learn to crawl, to walk, to swim, and yeah, not all our inspiration comes from software. There's also a part of inspiration that's completely non-software related. And this is a great example of it. That's the Codex Serafinianus, which was authored by Luigi Serafini and was first published in 81, although he had been working on it for quite a few years before that. And what I really, really like about this project, and I like saying that Luigi Serafini's work is like the true AI without AI. work. And that's because there's something about his work that really looks like something we can understand at first. We really think like, oh, this is a kind of natural history illustration of some specimens, and there's a description that I can read. But all of this is an imaginary language, so I cannot, we cannot understand what that's saying, and we cannot really know what is happening here, even though we can understand a few elements, like we can see legs, we can see like parts of a plant, but we can't really relate that to something that we have seen and experienced in the real world. And that's the kind of sweet spot that I feel absolutely fascinated by, this kind of semantic edge where something looks understandable in a way, and it isn't. So yeah, this is like part of my personal exploration in this space, and this is like from a series called Artificial Natural History. And what I did here was taking like hundreds and hundreds of images from natural history archives, like people who went on explorations, and illustrated what they saw, and like attempt to build an archive of specimens. And I tried to generate new variations of that. So yeah, that extended to various different life forms. In this case, these were mainly illustrations of coral. Very often I get asked if this is all Ernst Haeckel's work, and it contains some of like these two examples. They have some of Haeckel's illustrations, but the project itself isn't focused on his work. It really has like hundreds and hundreds of different authors to it. So just to mention that. And to me, this exploration of like looking back into the past and looking at how nature has been kind of cataloged or made sense of throughout time isn't something that stops with using AI. I really like to create physical pieces with my works as well, and these have been some of the explorations I did in this, where I learned about the cyanotype technique, and how Anna Atkins was one of the first people to publish a photography book. And I think she was actually the first person to publish a book of photographs. And this is in the 19th century. So I'm really inspired by how in her work, as a botanist, she used this technique to extract impressions from algae, for example, and to photograph them instead of illustrating them, because illustration implies that there's a subject looking at an object and then depicting it, whereas in photography is different. It's like, of course, there is a subject photographing an object, but it's a different mechanism where one is able to extract like an impression that's more like loyal to the original object in a way. So yeah, I don't know. I hope that makes sense. That's at least like part of my approach. So yeah, Feli, I don't know if you'd like to share a bit about this.
Yeah, so this was one of the first collaborative projects Fia and I did, titled Artificial Remnants, where we've been discussing sort of this notion of taking these artificial two-dimensional life forms and exploring them in 3D. And of course, this was, naturally a rather difficult sort of thing to do, because it, is way back when, before there was, any real established work with 3D and neural networks, or at least nothing that was impossible for mere mortals to run. I mean, nowadays, you have Point Eve from OpenAI and so on. It's a very different world. But back then, we didn't really have much. So a lot of our first exploring were just trying to hack together a solution. And this became interesting because we wanted to try and see from the data available, because honestly, there was, and there still is, almost no real data about insects in 3 dimensions. So one of the first things we had to learn was how to do data augmentation in 3D, which is, by itself, that could be a lecture on its own. It's fascinating stuff, but we had very little data, and we had to find ways of, basically tricking a 2-dimensional neural network into generating 3D, which with time we managed. But the series was about not only just generating these specimens in 3 dimensions, and bring them to life, but also using actually generating, their textures as well. But we also want to do, fine tune back in the old days of GPT-2, fine tune GPT-2 on textbooks and scientific literature about the insectile in order to generate not only their names but also anatomical descriptions. Basically, we were trying to enact a form of a speculative study of artificial life forms, sort of not their forms, their descriptions. And this has, been really interesting for us because it's also been, not just a digital work, but also physical. This is an 11-meter tall sculpture, inflatable sculpture in China, and the show we did year before last now, which, has this fun effect of inverting the normal hierarchy where you are very large and the insect is very small. And for those who were able to visit it, it was the inverse experience of, standing below this towering speculative creature. So for us, this has been an iterative series, and of course, as time has gone, we've, and algorithms have gotten better, and we've gotten a lot better at how we, improve data sources and make our own. We've been able to, push further and further into the qualities and sort of what they can do. But it's very important to mention here, we're not really interested in trying to recreate nature or in some way replace nature. This is more exploring because these might look a bit fanciful and weird and colorful, right? But the minute you go and look at the actual documentation of insect diversity out there, what we can do with a neural network basically pales by comparison. Every time we've done something and thought, wow, this is actually pretty, far out output we got here, at least on my Twitter, I scroll down Twitter a bit, suddenly there's some insane trilobite beetle that looks like, a mixture of a dinosaur and a beetle, and it's just like nature's basically like, hold my beer every time, and it's very humbling. And this is for us also important, that this isn't just about creating outputs, but it's about a process that brings us closer to the more than human world. That this is a way of also starting to understand how little we know, how do we engage, how do we create, a deeper connection with that world, and how can we try and sort of create compassion and connection rather than to see this artificial life. And this is actually in regarding what Sofia was saying earlier, this is actually sort of following the tradition of artificial life, where actually early studies of cellular automata and so on were actually used quite surprisingly successfully at times to help simulate and try and build a better understanding of the natural world. Sofia, if you'd like to jump in before I ramble away too much, that'd be great.
Yeah, sure. And yes, so this exploration that Feileacan mentioned extended to a point where we started asking ourselves more and more about what data are we using to feed these models. And, we started to realize that we're biased on a lot of different layers, not just that we are, selecting a specific part of the life cycle of a creature, like we're always looking at the creature alive in a specific setting, in a specific kind of maturity. Like we're not, when we photograph a beetle, or we look at photographs of beetles, like we're looking at them like in a specific stage, right? And we started to think more about 3D data, and specifically aquatic 3D data. And that's like something that is like extremely difficult to come by. If any of you know like an amazing aquatic data set, please let me know, because I still Like I know some people are working on creating 3D data, like 3D data sets, like scanning the 3D, scanning the seabed, and just to monitor coral growth. That's actually a really important thing to do as well. But 3D scanning or photogrammetry underwater is extremely difficult because light travels different underwater than it does on land. So yeah, this is something that became a problem for us because we really wanted to make a project about an aquatic ecosystem. And so we found ourselves struggling to find data about coral, and we partner up with a fellow artist, Joel Simon, who had built an algorithm, a genetic algorithm to grow three-dimensional coral. And so we felt like this was a good opportunity to make this part of the artistic statement. The lack of data is actually embedded in the project. The fact that, you know, we had to use artificial data to grow, to train an artificial neural network on it. A lot of engineers come and ask us like, why the hell would you want to do that? Like, that makes no sense at all. But to us, that makes perfect sense, you know, and that's the point of, in art, you can actually, you know, take something that annoys you and make a point about it in your project. And we had the chance of presenting this as an installation, and we got to 3D print them and create kind of tiny sculptures with them. And yeah, sorry, I went in too far, but
Yeah. So
yeah, well.
yeah. No. So Beneath the Inner Waves, as that project is called, has been sort of for us trying to also sort of not only just map out what data is available to us, what that turns into when sort of like distilled down, but also trying to use what we know about the natural world, you know, the knowledge that underpins genetic algorithms, the observational data, because it's also a matter of ethics, because, you know, just going out and wantonly extracting coral to 3D scan it is, you know, hugely destructive and not really on the table at all, if you ask us at least. So, and being present in delicate ecosystems is also, you know, something that's quite fraught, and we have to be very careful about how we collect data so as not to actually, you know, be destructive in that act. And this series here, Sediment Nodes, is the more recent one, which tries to touch upon communicating an experience that's often, you know, very hard to experience yourself. So Sofia introduced me to diving, as she's very much an avid diver. And one of these interesting things is when you dive into sediment-rich water, everything is, you know, gray, visibility is terrible. But if you have with you a small flashlight, and as you descend into the depths and things start to get dark, you take this little flashlight and shine, you sort of get this little world of color full of life that sort of kind of flourishes in front of you. And for this series, we used whole pipeline approaches to try and recreate some of that complexity, texturality, you know, and vivid life that is actually there, but that, you know, in sediment-rich waters you would dismiss as gray and soup-like, because it's all about, you know, getting close enough to understand, to see what's actually there. And often that means, especially in terms of the aquatic, we have to enter a world we are not actually welcome in the sense that we're not evolved to survive in it. You know, we cannot dive without equipment. We cannot stay in certain pressures for too long without having adverse effects. So we're just visitors in this, you know, world, and it's very hard to connect with that world because, you know, most of us just don't have the opportunity to, you know, strap on in the daily life the equipment you need and hop off into the ocean. You know, it's usually quite reserved. And how can we use these tools to try and touch upon some of those, also aesthetically, some of those moments we have? Yeah, so, and this brings us to the final project we wanted to talk about today, which is a little bit different, but it's touching, you know, continuing the red thread. And the question is here, which do you think really has the most presence and, you know, understanding online, and, you know, most likes, so to speak? Because these are both, you know, critically endangered species, but as you can probably imagine, the red panda generally is, you know, if you search for red panda, you're going to find a lot of posts on Instagram, right? And because a lot of our work is, about the aquatic and about more than human life, we cannot help but daily sort of touch upon this issue of critically endangered species. And as we started to sort of dive deeper into this, what we found was that there were some, 8.3 million species estimated on this planet. But the fact of the matter is that we've only so far catalogued maybe 1.2 of these. And of course, of that, we only know around some 8,700 to be critically endangered. And naturally, that's probably not a very precise estimate. And also, if you look at, for example, the red list, most of the listings of these species look like this. You have their scientific name and sometimes just the last assessment done. There's very little data. Some, of course, have a common name and images, but that's not the majority of them. So we wanted to sort of kind of do a speculative reconstruction. So we took just, fast forwarding, say, 50 years. If most of these species are gone, what data do we have? How can we reconstruct them? Like, do we know enough about the world to bring them back? So we took the largest data set we could find that was publicly, openly accessible and, with permissions to use, which featured some 10,000 species as categories across 2.7 million images. And that sounds like a lot, right? 2.7 million images as a data set, a lot. Remember, we've only catalogued about 1.2 million species. So, and of that 2.7 million images, we're only representing 10,000 species. So we have the tree of life, which right now is about 1.2 million species. And we have this tree of known data in this context of this model, which took a whole cluster of GPUs training for over a month straight to get done. This was, back in the day when transformers models were cutting edge. So, 8 months ago. But so we had this tree of known data. So what we did was we built an algorithm that mapped the critically endangered species with its nearest genetic neighbor within the tree of known data. And then we used that category to help try and regenerate, to create a representation with the help of what data we had in the neural network to generate a representation of that species. For example, here, if you go to the next slide, Sophia, we have the peacock tarantula endemic to India. And here in this case, you see that there is a bluish spider that there was, a relatively close match within the tree of known data from the neural network and the actual tree of life. But moving forwards from there, with the mangrove finch, on the other hand, we start to see that while the knowledge of bird is there, we're not even close to really representing accurately or in any way recognizable way these species. And of course, this continues as we go deeper into this. And while we were able to generate, a lot of fascinating representations of animal life in this sort of somewhat natural history style illustration, the reality of it was that most of these really don't look very much like the species they're actually meant to represent. And this creates a sort of interesting tension where we risk losing all these amazing species that are really critical and that, are not as well represented as, big mammals like pandas, lions, tigers, etc., but are actually still critically there. And so a lot of this series has been trying to explore how can we sort of, underline just how little we know about this in a way that, also hopefully inspires some kind of curiosity or interest in what do these actually look like? If we find a picture, is it close or not? And we've been, very lucky to be part of last year's Midnight Moments in Times Square. So for a whole month, we got to have a little jab at, hey, please think about critically endangered species a little bit there. That felt nice. Yeah, I think that's really thank you from us in terms of I hope we're not too over time. But yeah. Happy to talk if anyone has questions.
Thank you so much, both of you. If you are muted or you have your camera off, you can leave this clapping emoji. So we are still we have some sense of clapping. Wow, that was so interesting and really nice to. Oh, there's some claps. I hear some nice mix of virtual and sonic claps. Well, yeah. Really, really cool. Thank you so much for your presentation. And we still have about 15 minutes for questions. I saw a lot of questions in the chat already, so that's really good to see. And I'll try to go over all of them. If you have more, please post them there. So there was a question by Emmanuel Larino about your latest work, intertidal samples, which he really loves, or they really love. So is it the latest generating individual elements that you compose? Is the AI generating individual elements that you compose later, or are you training the data set to generate the full composition? That was one question.
So actually, that's kind of both. So yes, there are individual specimens being generated, but simultaneously with that, we generate a composition, or rather a kind of an entangled base upon which then the specimens are composed. So it's a two-step process. So in order to have these interesting compositions, we generate a composition which then the specimens are mapped to and placed upon. So it's a bit of a both there. It was kind of a sort of weird sort of feedback loopy kind of thing, but it was, we also wanted to try and touch upon, these all, again, with the natural history, but from a different angle, but, these fantastic specimen compositions. And at the same time, with the drop of water, when you look at it under the microscope, suddenly this little drop of water is a universe of elements. And we sort of see them as just this thing, but the minute you put two drops together, it expands and changes. And it's sort of how we're always seeing things within these framings, which is fine, of course, the only way we can, but how can we sort of become more aware of that we're looking at with such, sort of narrow vignettes of the world. So it was kind of trying to generate like little bundles that would then be populated with life, but that we could easily generate two intersecting and then expand that. There was no time for that series, but yeah.
No, but that's really interesting. So it's kind of a back and forth with the algorithm.
A lot of our work really is like that. It's about building feedback loops that are productive or somehow help us, explore or dive deeper into something. So a lot of it is semi-performative in many ways, a bit like the critically excellent project we showed last. A lot of it is about going through the motions and performing this exercise, even though we know it's already going to be futile or somehow not actually, achieving realism. But that still doesn't mean it can't actually be helpful and, at least for us, meaningful on a conceptual level.
Yeah, and that's also, I think, really interesting in your work that you have these creatures. And they're not real, but they're somehow telling the story of real animals as well. And really well in that ties a question by Max Frischknecht. Really sorry if I don't pronounce your name right. And the question is, how do you deal with the friction between creating interest and respect of nature through your work and the large environmental problems related with AI, such as power consumption to train models? So that's a difficult question.
Yeah, it is. Honestly, this one's tricky. I mean, over time now we have, our own little set of GPUs here at home, and, we buy from a sustainable energy company. And the reality is the energy we use, especially since, it's not like we drive a car every day to and from the studio, the reality is the amount of energy we use compared to the incredible amount of energy that goes to driving, the product recommendations on Amazon.com is, in reality, it doesn't really feature. I mean, this is a problem when we look at large language models like ChatGPT or DALL-E, where we're talking about literally thousands of GPUs burning, for months to train models. Compared to, where we work, especially when we work a lot with GANs, which is, these days become, thanks to advances in GPUs, become, relatively small, fast things. It's very difficult. We see this as sort of something we're iteratively trying to improve upon, find ways to, ever work more sustainably and not just, go off the deep end in terms of large uses of large data sets, large, amounts of GPUs. But it's tricky. There is you can't disentangle yourself from the world and become sort of platonically environmental, I'm afraid, but
Yeah.
we try.
Yeah, but that's also really good to hear, because I think there's also a difference between training something at home at one's own computer, where you have, you know, you can see when it's running, you can make decisions into like how you use, like what kind of energy you use, and then the bigger models, like for instance, DALL-E or Stable Diffusion, that are hosted somewhere else, and you access, you have access through an interface with. So that's already, I think, in a way, a conscious decision, or
Absolutely.
there's already clearly choices that are being made. And then there was another question that I thought was also, really nice in collaborate, like kind of with the work, and especially I think the last work you showed by Tim Redfern. What is the purpose of artificially generated pseudo-organisms? What can it teach us, or what is its meaning? And then do you have any way of saying whether a particular life form is a success other than satisfying and aesthetic? That's two kind of questions.
Well, I can hop in here. I guess in a way you could say they don't really have any purpose. Like because we're making it as an art project, you could, I could start a whole rumble about like, what's the purpose of art? Like, can you really find like, what's the true functionality that it has? And that's a really long discussion.
Yeah, let's not go into what is art.
Am I making it for myself? Am I making it for somebody else? And I don't have like a specific answer to give here that's comprehensive to everything. What I can say is like how it was born, and at least how it was born for me, that was born from a sense of curiosity. I wanted to kind of look at these arrangements and kind of life rearranged, and it's also very, high level layer, that's like very superficial. It doesn't go deeply into what it really means to like what a life form really is. So yeah, like just to, it's important to, for me at least, to always acknowledge that all the work I do is biased in one or another way. And you could, in a way, argue that all art is biased, and that's by design. That's like the whole point of the human experience in a way. It would be very different if I were creating like a consumer product where, a bias could like be really, really harmful in a way. But you could still say like, okay, I'm open to discussion of like how, even what we're doing can be harmful. But I think it's different.
I think it's really different. Like, for instance, with the last work, it's art, but there is like, you are addressing these questions of like what the meaning is and like how it relates to real life. And maybe it's not in language, but it's in I think it's very inherent in the project. So I think this question was also before you showed that work. I thought there was another interesting question by Scott McLeod, which was about the jellyfishes you showed earlier in the presentation. Would you describe these jellyfish that you're showing in now and just previously in the collages as virtual, or actual, real, physical, or something else? Beautiful.
Well, they're, having talked to marine biologists, they're absolutely not real in the sense that there are some, reality-defying combinations of features and arrangements, even though the thing is they embody a jellyfishness that we recognize, because this is the image we have as a culture and that we record as jellyfish. And it's more about this making tangible this this essence of what we as humans understand as jellifishness, not what jellyfish actually are, because the reality of the jellyfish is so much more. But as a society, as you know, the image has propagated through, and what we consider jellyfish has become this one thing. Naturally, that's what we're met with. So I wouldn't really call them either virtual either. I'd say they're more a bit like kind of a mirror in a sense, and that's they touch upon, you know, something, reflect back upon us, our own notions and understanding of the world. I hope that makes sense. But I'm glad you find them beautiful. I've had some marine biologists say some of the combinations are a bit terrifying. They would never like to see them in reality. But that's a different thing.
Ooh, I would not like to find any jellyfish, but I think your jellyfish would be particularly dangerous, but also beautiful. There's a question by TRPTI Sangvi. I'm really sorry for the pronunciation. So it's about kind of the balance between randomness and determinism. So they ask, are there parameters within the model for randomness versus determinism? And I think that probably depends per model, but have there been ever surprises that led to a novel discovery, or that a project completely changed because of that discovery?
Well,
to address yeah, go ahead.
Well, I can say that something that happens a lot, like within AI, is overfitting, and that's when the model actually like stops creating something that better to put it this way, it starts creating something that's way too close to data set, to the point where, you know, like it's hard to distinguish data set from what the model is creating, and then it kind of defeats the whole purpose of training a model in a way, you know, because you don't get to kind of fully recombine the data set if you're just recreating the same information. That, you know, and many of our models are overfit, and that doesn't, like, I mean, it depends like how you use it, you know, like how you want to use it. Like you can have a model that's overfit and still remix like what you get out of it enough that that it still looks different, because we have this whole feedback loop where sometimes, you know, that data is feeding back in, and then we create kind of many layers to the actual output that you see. So I guess that's our way of creating artificial randomness in a way.
Yeah.
I don't know, Feli, if you want to add something.
Nice.
Yeah, I think like, yeah, this is also the thing is that, and it's important to remember that all neural networks within current architectures and all models trained upon them are limited. You know, even with DALL-E or Stable Diffusion that appear infinite at first glance, they have hard limits to their knowledge. You know, they are based upon data available online, which, while it's a lot of data, isn't actually close to representing the actual diversity of reality that we're in. So by definition, and that's why we talked about meditations earlier, for us, these are a way of enacting, you know, a meditation where we create space for serendipity, you know, because very often if I'm curating a data set, let's say we've been gathering photos of seashells, we've been taking, you know, out taking photos of seashells, then afterwards when cleaning and sorting the data set, cropping and so on, you know, and training the model, suddenly you realize like, oh, actually I have a tendency to prefer these, you know, more elongated shell. I've kind of discarded, you know, the short, broken, stubby ones, because I just, on a subconscious level, did not consider those to be relevant or valid. And I didn't think about it and didn't have that conscious relationship to the data before training the model, and sort of like going, oh, wait, you know, and what is, you know, a valid state in the natural world? You know, if you're creating jellyfish, you know, we had to filtered out images of jellyfish beached on the sea. The thing is, while we did that, you know, for the clarity of it, it's also saying, you know, it's also begging the question, well, what is a valid state of jellyfish? And a jellyfish that's dead, that's washed up on the beach and ready to become, you know, food for other organisms, is actually a valid state of jellyfish, an important state of jellyfish. But it didn't quite fit, you know, or make it easy for us, you know, and that's that kind of sticky entanglement. We can't really get away from the fact that no matter what you do, you're going to be within a limited space. But I think this can help us as a practice be more aware of the fact that we have so many biases and for granted that, you know, shape how we experience the world. And that's fine. That's just being human, but it's about trying to find ways to become more conscious and aware of how we are in the world. Sorry, ran over.
That's a beautiful, beautiful point to, I think, so we're already past time. I thought that was like a very nice way to kind of round off our talk series. I'm very sorry I didn't get to ask all the questions you asked in the chat, but there were some really interesting things, and it was really, really great to have you here, all of you, but especially Sofia and Feileacan. So if you want to see more of their work, you can find it via their website, which is Entangled Others Studio, right? Yeah.
Yep, that's right.
And then I think we will round it off here. I hope you'll be joining us in the next 3 weeks for the next lunch lecture series. Thank you so much.
Thank you so much for having us.
Yeah, thank you so much for joining us and showing your amazing work.
Thank you, everyone.
Bye, everyone.
Bye-bye. Thank you.